Hello guys, in this video we're gonna solve homework 11. So homework 11 is about logical operations like and or or something all such operations. It was relatively easy and very important homework because it covers mostly concepts that you will see all the time in your computer science, or even computer engineering, courses, other courses, and even your life afterwards. So let's start by the first question here. What will be the value of AL after executing the following code? So in the beginning, I am moving this value, this hexadecimal value, to AX. Okay, then I'm ending AX with 00FF. Okay, so let's assume, just in general case, like you have a Boolean variable Y. Y is a Boolean variable. That means it can be 0 or 1. Okay, so basically, if you ended Y with 0, regardless of the value of Y, the output will be 0. I'm sorry, it will be 0. And if you ended the Y with 1, the value will be Y. So if, for example, if Y is 0, 0 and 1 is 0. And remember, Y is 0, so that's Y. If Y is 1, 1 and 1 is 1, which is again the value of Y. That's why, Y or any value, any logical, any Boolean variable ended with 1 will give you the same Boolean variable. Okay. So basically here, the short answer is, 1 and 2 will be zeroed. 1 and 2 hexadecimal will be just zeroed. 3 and 4 will not change. So the output or the value of X after executing, this code, or after executing basically and the X 00FF will be 0034. Okay, hexadecimal, of course. But if you want to make sure, you can just make it, like bit by bit. So let's write AX. So 0001. This is the 1. Then this is the 2, the 3, and the 4. Okay. Then it will be ended with 00FF 0 0 F F. So we're gonna end bit by bit here, bitwise. So 0 and 1, 0, 0 and 1 is 0, 1 and 1 is 1, 0 and 1 is 0. Look at, compare this one or this value by this value. It's exactly the same. It is a 4. Let's go to the second 4 bits. 1 and 1 is 1, 1 and 1 is 1, 0 and 1 is 0, 0 and 1 is 0. Compare this one by this one. It is the 3, it's exactly the same. Then here we're gonna end with 0 all the time. So the output will be 0. Let's check. 0 and 0 is 0, 1 and 0 is 0, 0 and 0 is 0, 0 and 0 is 0. So look, it's 0. 1 and 0 is 0, 0 and 0 is 0, 0 and 0 is 0, 0 and 0 is 0 again. So it's all the time 0, 0. So basically, the value of L, of course, AX will be 0034. Remember, AX is composed of 2 registers, AH, and the least significant 8 bits is basically AL. So AL will be 34H, correct decimal. Second question, what will be the value of L after executing the following code? Now it is the same question, but it's an OR operation. So again, let's assume you have a Boolean variable called Y. Y can be 0 or 1. This is just Boolean variable, 1 bit. So if you OR Y with 1, this will give you 1 all the time, regardless of the value of y. And if you OR it with 0, this will give you, the value of y. Exactly the same. I mean, it will not change. Okay. So let's check. So for example, 0 or 1 is 1, of course. 1 and or 1 is 1. So all the time, if you OR with 1, you get 1. Now let's check the second, rule here. 0 or 0 is 0, and remember y is 0, so this is basically y. 1 or 0 is 1, and again y is 1. So basically you get y, if you OR with 0. So the short answer here is that, ax after this operation will be basically, since you are ORing, so this will not change. The stuff that will be ORed with 0 will not change. So 1, 2 will not be changed. And 3 and 4 will be ORed with FF. So these are 4 1s and 4 1s. So this basically will give you 4 1s and 4. So this will be the the value of x after making this operation. And of course, this is AL. So the correct answer is here is FF, but we can again do it, step by step bitwise. So we're gonna write again AX, it's 0 0 0 1, 0 0 1 0, 3 is 0 0 1 1, 4 is 0 1 0 0. And it will be ORed with 0 0 FF, 0 0 F F. And remember here it's an OR operation. So 0 or 1 is 1, 0 or 1 is 1, 0, 1 or 1 is 1, 0 or 1 is 1. Look, this is 4 1s, which is F. Again, 1 or 1 is 1, 1 or 1 is 1, 0 or 1 is 1, 0 or 1, again 1. So again F. 0 or 0, 0, 1 or 0, is 1, 0 or 0 is 0, 0 or 0 is 0. So look here, this one is exactly equal to that guy. So again, ORing with zeros does not change the value. 1 or 0 is 1, 0 or 0 is 0, 0 or 0 is 0, 0 or 0 is 0. Again, that one and that one here doesn't change. Okay. What will be the third question here? What will be the value required below to toggle each bit in AX? So we want to toggle. Toggle means, invert basically. It takes a complement. Okay. So if you have a variable, again, Boolean variable called y, this y can be 0 or 1. If you want to toggle y, basically you're gonna have y bar. That's it. Y invert. Okay. So if y was 0, y bar will be 1, or the toggle of y will be 1. If y was 1, the toggle of y will be 0. Okay. And remember, we learned that XOR can do that for you. Okay. If you XOR with 1. Okay. So let's do this. Let's prove that. So y XOR 1. This is all the time y bar. Let's check how. If y was 0, 0 XOR 1, these are two different values. So if you have two different bits, this XOR will give you 1. Look, y, which is 0, becomes 1. That's the inverter. 1 XOR 1, this will give you 0. Why? Because they are similar. Or the number of ones is even, whatever you like. So the first one here, the number of ones is odd. The second one here, the number of ones is even. Or you can say, these are two different. So the output is 1. These are two similar. So the output is 0. And again, compare. So y was 0. Y was 1. It becomes 0. So again, it's inverted. So whenever you XOR with 1, you invert the value. Okay, so we want to invert by 1. Remember, AX is 16 bits. So we want to, XOR with 111. Sorry. 1111, which is F hexadecimal. So that's the correct answer. So you don't need here to know how the value in AX before that. You don't need to know this. Okay, because regardless of the value in AX, okay, once you do the XOR with ones, you're gonna get the toggle. Let's have an example. Let's take this example here, like 1 2 3 4 0 0 0 1 0 0 1 0 0 0 1 1 0 1 0 0, and you're gonna XOR with 4 Fs. Let's check if we're gonna toggle each bit or not. 0 XOR 1, they are different, so this will give you 1. 0 XOR 1 will give you 1. 1 XOR 1, they are similar, so this will give you 0. 0 XOR 1 different, so this will give you 1. Compare this guy with this guy. It's just the inverted. 1 XOR 1, similar 0, similar 0, different 1, different 1. Compare this guy with this guy. Different, similar, different, different. Compare that one with that one. Similar, different, different, different. Compare this one with this one. Okay, good. And you can have many other examples. Okay, the last question here, what will be the value of the flag register, the flag register bit carries, the carry flag basically, and the zero flag after executing the following code: compare EAX and EAX. Okay, so we also studied the compare instruction in the logical operations. Okay, and maybe it's a compare, it's it's more of arithmetic operation, although it doesn't change its operands. Okay, and we studied that compare is just like subtract, or similar to subtract. So the effect of compare instruction on the flag register is like the effect of subtract instruction on the flag register, although it doesn't change the operand. Okay, so what we do here, since it's a subtract, we're gonna subtract AX from AX. So of course AX minus AX is just 0. Okay, 32-bit zeros. Okay, so we're gonna have 32-bit zeros. So I'm not gonna write them all. 32 bits of zeros. That's the output of the subtraction. Okay, of course, since all of them is zeros, then the zero flag will be 1. Okay, and in that operation, when we subtract, like for example, whatever, let's assume that AX have 32 bits. Anyway, so let's take an example of just 8 bits, something like this. This is not AX, this is just 8-bit subtraction operation. So 0 minus 0 is 0, 1 minus 1 is 0, 0 minus 0 is 0, 0, 0, 0, 0, 0. So you don't have a borrow here. So of course, in borrow is like the carry, in the addition instruction. So since you don't have a borrow here, then the carry flag, which becomes a borrow flag basically in the subtraction operation, is 0. So that's also the correct. So of course here you should choose both. Choose a value for CF and the value for CF. Okay. If you choose all of the 4, I'm gonna give you 0, because of course that's not an answer. You should choose either ZF is 1 or 0, either CF is 1 or 0. Okay, guys, that was it for homework 11. Thank you very much for watching, and see you in another video. Bye-bye.